Why your hands can feel things before you touch them. Put your hand into a bag of rice and hunt for a coin. Not with your eyes, no cheating, just the hand. You stir around like a very small archaeologist with no funding, and somehow, after a few seconds, your fingers find it. But here's the odd part. You may sense the coin a tiny moment before you properly touch it. Not like a superhero. Not like you can wave your palm at a wall and detect plumbing. Please do not start charging people for this at parties. It is smaller than that, quieter than that. A faint change in the material. A little pressure message traveling through the grains. A whisper from the rice saying, in its limited rice vocabulary, something is over here. For most of human history, we have treated touch as the honest sense. Sight lies constantly. Hearing misbehaves in echoey rooms. Smell has the emotional stability of a haunted candle shop. But touch seemed simple. Skin meets object. Object says hello. Brain receives memo. In 2025, researchers reported evidence that human touch may be a little stranger than that. In the right material, your fingers can detect a hidden object before direct contact. The name for this is remote touch. And the reason it sounds like a fake psychic skill is deeply unfair, because the actual explanation is much better. It starts with birds. Shorebirds such as sandpipers and red knots spend their lives walking across wet sand and mud, looking for tiny animals buried below the surface. This is a ridiculous job when you think about it. The prey is hidden, the bird cannot see it, the mud looks like mud, because mud has never been famous for visual variety. And yet these birds jab their beaks down and find food with impressive speed. They are not guessing at random. They are reading pressure. When a bird pushes its beak into wet sand, the grains and water push back. If something solid or living is buried nearby, it changes how that pressure travels. The beak feels those tiny differences. It is not magic. It is physics wearing a very thin disguise. The bird is feeling a hidden thing through the material around it. So a team involving researchers from Queen Mary University of London and University College London asked a beautifully simple question. If a bird can do this with a beak, can a human do something similar with a finger? This is the kind of question science was made for. Not every experiment needs a particle accelerator. Sometimes science is 12 people, a box of sand, and the quiet suspicion that your index finger has been underappreciated. The researchers buried small cubes in sand and asked participants to find them using one finger. The people could not see the cube. They were not meant to stab around wildly, like someone trying to win an argument with a beach. They moved their finger through the sand in a controlled way, while the researchers tracked where the finger was and when the person thought they had detected the hidden object. The important question was not, can people eventually bump into a cube? Anyone can do that. Given enough time, even a spoon can make a discovery. The question was sharper. Could people sense the object before direct contact? And the answer, according to the study, was yes. Participants could sometimes detect the buried cube before touching it, with reports describing detection distances up to roughly 7 centimeters away, and a median closer to a few centimeters. That may not sound enormous. 7 centimeters will not help you locate your car keys from across the house. It will not allow you to identify a biscuit through a sealed cupboard, which is tragic but scientifically understandable. But for touch, 7 centimeters is astonishing. Touch is supposed to be the sense of immediate contact. It is the bouncer at the door of reality. No contact, no entry. Here, the door appears to open slightly early. The human participants were also surprisingly good at not fooling themselves. Their precision was around 70%. The team compared this with a robotic system fitted with a tactile sensor and trained with a machine learning model. The robot could also detect signs of a buried object, but it produced many more false alarms. Its precision peaked around 40%. In other words, the robot was enthusiastic. It saw meaning everywhere. It was the friend who says, "I think I found it," every 6 seconds, while standing in the wrong room. The humans were more cautious, less dramatic, more annoyingly competent. And that is interesting, Because the human fingertip is not a blunt instrument. It only looks like one because we use it to press lift buttons and remove crumbs from jumpers. Under the skin, your fingertips are packed with tiny biological sensors called mechanoreceptors. They detect pressure, vibration, stretch, movement, and changes in force. They are so sensitive that your hand can tell the difference between silk and paper, a smooth mug and a cracked one, a phone screen, and the tiny crumb you will now be thinking about for the next 3 minutes. When your finger moves through sand, it is not simply pushing through a dead pile of particles. Sand is a crowd. Each grain leans on another grain, which leans on another grain, until the whole thing becomes a tiny public transport system for force. Push here, and the pressure travels there. Put a solid object under the surface, and the flow changes. The grains cannot move in quite the same way. They pack differently. They resist differently. They send back a pattern that is slightly wrong. Your fingertip feels that wrongness. Your brain, which spends its entire life trying to guess what is about to happen before it has to admit uncertainty, interprets the pattern. Something solid. Ahead. Prepare the finger. That is the trick. You are not feeling through empty air. You are feeling through a material that carries information. The sand becomes the messenger. The fingertip becomes the reader. The brain becomes the suspicious manager who has seen enough to know there is probably a cube involved. Once you understand this, ordinary life begins to look slightly more impressive. Think of your hand searching for keys at the bottom of a bag. The bag is a private landfill. Receipts, coins, tissues, lip balm, one ancient mint, and a cable nobody can identify. Yet your fingers move through it and suddenly stop at the keys. You did not see them. You did not plan a route. Your hands simply performed a small investigation and handed in the result. Or think of your foot under the duvet, looking for a missing sock in the dark. The foot has no eyes. It has no map. It is operating in a soft cave of cotton and regret. Still, somehow, it finds the sock. Not always. Let us not flatter the foot too much, but often enough that you never considered the achievement. The world is full of these tiny tactile searches. A child digging in wet sand. A hand finding a coin in rice. Fingers moving through a pocket and recognizing the difference between a house key, a button, and a piece of lint with suspicious confidence. We call it feeling around, but that phrase makes it sound clumsy. What is happening may be closer to active sensing. Your hand moves, the world pushes back, and your brain updates its guess. Touch is not just receiving. Touch is asking questions. Every movement says, "What are you?" Every change in pressure answers, "Not what you thought." This is where the story becomes bigger than a cube in a box of sand. For centuries, we have liked the idea of 5 senses because 5 is tidy. Sight, hearing, smell, taste, touch. A neat little list. Very school poster friendly. Unfortunately, the body did not consult the poster. You also have balance. You have proprioception, the sense of where your body parts are without looking. You have internal signals from hunger, heartbeat, breathing, pain, temperature, and the strange, deep knowledge that you should not have eaten the second serving quite so confidently. The human body is less like a 5-button remote control and more like a dashboard designed by several committees during a thunderstorm. Remote touch adds another complication. It suggests that touch is not always confined to the exact border of skin. Under certain conditions, the world outside the skin can become part of the sensing system. Not because your hand is beaming out invisible energy, because materials carry mechanical information. The grains touch each other. The grains touch your skin. Your skin signals your nerves. Your brain makes a prediction. The object is not touching you yet, but its presence has disturbed the material that is touching you. That is the narrow but wonderful truth, and it is important to keep it narrow. This is early research. The human study involved 12 participants. It tested a particular task with a particular object in sand under controlled conditions. That does not mean humans have a new universal superpower. It means researchers have found careful evidence for a tactile ability that was not properly documented in humans before. That is still exciting. Honestly, it may be more exciting because it is not magic. Magic would just shrug and say, because mystery. Science has to do the harder thing. It has to explain why a finger moving through sand can behave a little like a sandpiper's beak on a beach. It has to show how pressure travels, how grains jam and shift, how skin detects forces, and how the brain turns those tiny signals into a useful guess. That is the real wonder. Not that the body breaks the rules, but that the rules were stranger than our simple version. The next time you see a child digging at the beach, watch carefully. Their eyes may be elsewhere. Their attention may be divided between the sandcastle, a snack, and a very serious dispute about whose bucket is whose. But their hands are busy. They move through the sand, pause, change direction, and suddenly return with a shell, a bottle cap, or some mysterious object every adult wishes had stayed buried. The child thinks they are playing. They are. They are also running a small demonstration in tactile physics with excellent enthusiasm and poor hygiene. Long before anyone gave it a name, humans were already using remote touch in beaches, bags, pockets, gardens, and kitchens. Your hands have been reading hidden messages in matter while you were busy thinking about lunch. And that is the quiet charm of this story. Your body is not waiting around for you to understand it. It is running clever little systems in the background. It predicts, it samples, it tests the world. It reaches, in tiny ways, beyond the obvious limits. You thought touch began when skin met object, but sometimes, in sand or rice or other grainy materials, the story begins just before that. A buried thing changes the pressure changes the grains change the feeling in your finger, and your brain, that restless little prediction machine, leans forward and says, there, something is there. Which leaves one excellent question. If touch can do this much without us noticing, how many other ordinary things your body does every day are secretly much cleverer than they look? If you enjoyed this strange little journey, subscribe and help us reach 1 million curious minds. There are many more weird facts hiding in plain sight, and we intend to bother all of them.